Hello. In this lab example, we're going to use the Tiny13 and write a small program and look at how the flags change in the program. So I've already written a program, which is here, of course, as you can see. It has some loads, add, decrement, and a subtract. Above the program, I wrote down a little comment to help myself remember how to compute the V flag and the C flag. The C flag is unsigned, so let me put that in here. The C is unsigned and the V is signed. All right. Now we'll go down to the program and see what kind of answers we get for each line. The first line is a load. We're going to load R16 to 255, and I've already computed the result. I'm going to bring it back in here. You can see the answer for this load. The unsigned is 255. The signed equivalent value of 255 is a -1. And the hex equivalent of 255 is an FF. These are three different ways of saying the same thing. So we're going to use all three variations of the same thing to help us with the flags. Let's move over to the flags for this one. If you look in the book, the load says it does not affect any flags. That means whatever we had before is what we will have now. And since we don't know what we had before, we don't know what we have right now. So I'm going to put them as dashes. Next line is a load 17 with the number 2. So register 17 will be a 2. And that is expressed as a 2 or a 2 and a 2 and all of these different ways of looking at it. The signed number is a 2, the hex number is a 2, and the unsigned is a 2. Well, this is a load once again, and load doesn't change the flags, so I will put down a dash for the flags. Line number 3 is to add register 17 into register 16. Well, 2 more than 255 is a 256, 257. 257 doesn't exist. It's 1 more than 256, so the answer is a 1. Again, 255 plus 2 is a 256 and a carry. Let me phrase that again here. It's a 256 plus a 1. And since we can't have 256, we have just the 1. So the answer is a 1 for the unsigned, 1 for the signed, and 1 for the hex. Come on up here to the second line, the second row of the program, where we have this number line for the unsigned numbers. We were sitting at 255. We're going to go 1 more, which puts us at a 0. Then we go 1 more than that, and that puts us at the number 1. And that's why I got the 1 here. Well, for the flags, the book says the add will affect all of the flags, and we know that this is not a 0. So I'll put no on the 0. It's not negative. We cross the end line, the C flag, so the C flag is 1. And for the V flag, we are sitting right, let's see here, we're seeing, oh yes, here we are, we're sitting at the FF right here, and we're going to go 2 more than that, which puts us at a 0 and then a 1, and that never crossed the end of the number system for the V flag. So this means once again that the V flag was never set, or was never 1, because we never crossed the end line of the signed number system. Well, line number 4, I guess it is. We're going to decrease R16. Well, it was a 1. Now it becomes a 0. And that means we have a 0 flag is set. The negative flag is not set. Let's see here, the carry flag. Well, let's see. We were at a 1 and we go down to 0. So we were at a 1, we go down to 0. We did not go out the ends on the unsigned number line. So that's a 0. And likewise, for the V flag, we were at a 1 and then we go down to a 0. That too doesn't cross the signed number system. Line number 5. Decrease R16 once again. Well, we had a 0, and we decrease it, and we get a 255, or a negative 1, or an FF. Well, this is not a 0. It is indeed negative. We went from a 0 to a 255 by decreasing, so we did go out the end of the unsigned number line. So the C flag is a 1. The V flag just stayed in the middle and did not go out the ends. So the V flag is a not set, 0. Almost done here. When we load a register, you're not changing any flags. So I'll put a dash on the flags. And we were loading with an 80, that's in hex. An 80 in hex is 128 in the unsigned system, and surprisingly, it's also negative 120 in the signed system. And if you don't see that, take the 2's complement of this, and you'll see that it is negative 128. Or another way to look at it, the MSB is set to a 1, so we do know it is negative. And come up here to the number system line for signed, and you can see that the 80 corresponds to a negative 128, the biggest negative number in signed numbers using 8 bits. Well, the last line. Subtract 2 from this prior number. So I'm going to subtract 2 from 128. I get 126. Subtract 2 from negative 128, and you end up going out the ends of the signed system, and you end up being positive 126. So you're up here, you go 2 more to the left, and you end up here on the right as a 126. That's a 70. Now for the flags, this is not 0, it is not negative. We went out the ends on the V flag, and then lastly for the carry flag, we were in the middle of the range, somewhere up in here at 128 going down to 126. That did not cross the ends, so that's a 0. Well, there is the predicted flags for the program, and in part 2 of this I will show you how to run the simulator and take a look at those flags. So we're going to stop the video at this point and look for part 2 of this.